So next we move to the application. So we have look at an example about the spherical coordinate using, finding the volume using spherical coordinate. So now we look at another application of the triple integral. Okay, so actually the application for mass, you have seen this in double integral, and also the moment of mass you have already have seen that in the double integral, but they also have in a triple integral where the mass of the solid, so now we call that the mass of solid, not mass of the lamina. For mass of lamina we use double integral, for mass of solid we use a triple integral. Okay, but the formula of the mass for triple integral is the same, where you have to have the density function. Okay, and then the formula of the moment of mass with respect to yz plane, because now we have a triple integral, so we have the solid, so we call this as a moment of mass respect to the yz plane, with respect to xz plane, and with respect to xy plane. So the formula here is just like the mass, but you have to multiply by all these variable. So how can you know which variable that you have to plug in? So if they're asking about the yz, then you have to put x. If they ask about the xz, then you have to put y. If they ask about xy, then you have to put z. Okay. And just like the in double integral, we also have the center of mass or the centroid. So this again, the center of mass is actually the same as the centroid, but the difference is only when we have the density function here is constant. So when the density function here is constant, so the center of mass is called as a centroid. Okay, so what is the formula of the centroid or the center of mass? So you have to find out the x bar, y bar, and z bar. Okay, x bar, you have to use the moment of mass with respect to yz. Okay, how can you know that? Because you want it x, so you have to use the moment where there is no x here. So that's why we choose yz. So that is the way how can we memorize that the formula. Okay, and for y bar, so you have to use the xz, the moment of mass, with respect to xz plane, and for z, you have to use the xy. Okay, so I would say that the formula is just like the double integral, but because double integral we deal with the 2D, and for triple integral we'll deal with a solid. Okay, which means that we have a solid. On the double integral we deal with the region. Okay, so you have to know the formula. So which formula is the most appropriate formula based on the question given. Okay, so in triple integral we also can compute the moment of inertia given by the I. So this one is okay, for Isaac it is a bit different, not the same as in lamina, for lamina or double integral. For triple integral we call this as the moment of inertia of the solid about the x-axis, about the y-axis, about the z-axis. So the formula is it's not the same as double integral. So for the moment of inertia with respect to the x-axis, so you have to use a y squared and z squared. For y you have to use x squared plus z squared, and for z you have to use x squared plus y squared. So all this you need to know the formula. Okay, so now using the formula, so we want to look at the example regarding the application that I have shown you here. Okay, so looking at the example 1, so this is a paraboloid, and the application using cylindrical coordinate. But you have to bear in mind, in exam sometimes they don't asking you exactly what is the coordinate system that you have to use. So the hardest part is you have to choose which coordinate system is the appropriate one, is the most suitable one. So then in order for you to get some idea which coordinate system can give you a better answer, not answer, but the better way, because you have to do fast, right? Because maybe you don't have much time, so then you have to choose which coordinate system is the most appropriate one. So in this case, okay, maybe we just ignore this information provided because this is not given in the exam. Okay, find the centroid, which means that you have to find the x bar, y bar, z bar of a solid of constant density function, meaning that this one is not the center of mass but centroid. So the density function here is not given, so maybe you can just leave your expression delta is just delta. Okay, so the solid is bounded below by the, you have a this here, so this means circle radius 2 in the plane z0. So imagine right on the floor you have a circular region with radius 2 and bounded above by the paraboloid. Okay, so the this here is just like a volume, sorry, just like a cylinder, right? So meaning that you have a volume, you have a cylinder with radius 2 and bounded below by the floor z equal to 0 and above by the paraboloid. Okay, so now the important part is to sketch the graph. Okay, so now based on the information provided, okay, so we have this, so which means that on y-axis plane, y-axis, you have a circle with radius 2 centered at the origin. Okay, so this means it is just a cylinder, maybe very thin cylinder. Okay, with radius 2. So the bounded below by the z equal to 0, below by the z equal to 0, and above by the paraboloid. What is the paraboloid here? So given by z equal to 4 minus x squared minus y squared. It is a bowl shape, right? So your bowl is concave down and shifted 4 unit above, just like that. Okay, so then you have to know what is the size of the circle or maybe ellipse on the floor, because you have to combine this bowl and this cylinder and you will get a solid that we are looking for, that you have to find the centroid of that solid. Now you want to sketch what is the solid, the shape of the solid. So x, y, z. So because you might wonder the size of this circle or whatever curve that we can see on the right on the floor is larger or smaller than this circle. So you can evaluate that. You can determine that by so this one is z equal to 0. So you set z equal to 0. 4 minus x squared minus y squared. So then it will give you x squared plus y squared equal to 4. So right on the floor you have a similar size of circle. So this one 2, this one 2. So here you also have 2 and 2. So then we can see that when we join them together, so we put the cylinder, so because they have the same size on the floor, and that is your disc. Okay, so then what is your solid looks like? Again, we read the instruction here. We have a solid bounded below by the circle with radius 2. This one, below by the circle, when you can see that it is a circle with radius 2, right, on the xy plane, where it is a disc. Okay, circle, and then z equal to 0, and above by the paraboloid. So the paraboloid means that what we can see that the solid that we have is actually only the ball. Okay, so now we have to erase this one. Okay, when we say a solid, it should be closed. So then you standing like that because you want to determine the limit. Okay, since here your region is basically a circle centered at the origin with radius 2. So then it looks like the easiest way for you to find out or evaluate the centroid, we are using the cylindrical coordinate, where the z is z, and you can find out the limit of the r and theta directly from your region. So so maybe you want to say that why don't we use the spherical? So as I mentioned before, the spherical should be, you have to find the phi and the rho. So in this case, there is no information about the rho, and there is no information about the phi. So that's why, and if you want to use the Cartesian, so it is a bit complex because you have to deal with the plus minus square root using this region, the equation of the circular region. So the easiest way here is we solve this using cylindrical coordinate. So as you can see here, the instruction, there is no statement say that you have to use a cylindrical coordinate. So meaning that you can use the spherical and you can use the Cartesian, but I'm not sure whether you can get the correct answer or not. Okay, so now we already have the solid. Okay, then we go back with the formula. Okay, so you are looking for centroid. Why we have centroid? Because our density function is constant. So I just put because they don't put the value, constant value, so I just use the density is delta. Okay, so what is the formula to get the centroid? You have to find the x bar, y bar, z bar. So I don't like this question actually because there are so many things that you have to compute. Okay, so hopefully in exam you don't this particular question given. Otherwise you will take a bit longer time to find out. But still, it is okay to be done as a out of the exam, because the exam you are running out of time, right? Okay, so the formula of x bar, moment of mass, because that is x, so you have yz over the mass, and m xz divided by the mass, and then m xy divided by the mass. So first you need to compute the mass. So what is the formula to get the mass of solid? The mass of solid using triple integral, the density function is constant dv. So now we are using the cylindrical coordinate to solve. So the density function is delta. So we use this cylindrical coordinate. So the formula of dv is r dz dr d theta. Okay, so now we want to get the limit of theta, where you can get it from the r and the theta, you can get it from the region. So this is your region. You have a circle with radius 2, so r 0 to 2. Okay, and your theta, you have a complete circle, so 0 to 2 pi. So we can directly put the limit 0 to 2 pi, 0 to 2. Now about the z, you have to look at from the solid here. So imagine this is you, and who is covering you down here, or who is become your base. So the base here is belong to z equal to 0, and then who is covering you? So your cover is because from this equation, paraboloid. So 4 minus x squared minus y squared. Okay, so then we put the limit 0, 4 minus x squared minus y squared. Okay, so then we can evaluate the triple integral now to get the mass. So for your own exercise, so I don't want to show you every single step to get the triple integral of this. So I just give you the final answer for the mass of the solid is 8 pi delta. Okay. So next we want to start to get the centroid, but before that, just look at the your solid here. Sometimes you don't need to compute every single x bar, y bar, and z bar, because from the solid that you have sketched, you can determine directly where is the x bar, y bar, or z bar located. Okay, so x bar, y bar, z bar is just like a centroid, the center, the stability point. Okay, so you can see that if your solid is in this form, and they are symmetrical about the z-axis. You can see that they are symmetrical about the z-axis, right? Because the shape of this, I mean, if you look at for the region itself, so the region for the first quadrant, second quadrant, third and fourth, they have a similar size of region. So similarly, your solid here, so this one is symmetrical about the z. So you can from your sketching, you can determine the stable point of this solid, where it is obviously the center of the on the xy plane. You can see that because they have the same size on the first, on the second, and the third and the fourth quadrant, the center of this circle is at 0, 0. So now we know that the x bar and the y bar should be located on the at the origin here on the xy plane, which means that somewhere here, I mean somewhere along the z-axis. So that is the stable point or the center of mass. So you don't need to compute the x bar, y bar, because you know that from the behavior of this particular solid, because the center on the xy plane is at 0, 0. So we know that the x bar, so the x bar is at 0 and y bar is at 0. So your work is only to get the z bar, because we are not sure what is the stability point or the centroid along this z. It can be here or here or here. So we cannot estimate that. Then you have to compute. Okay, so now you want to get only z bar. So you have to find this only, this one. So we have done the finding the mass. So now we want to get the moment of mass with respect to xy plane. So still the same. We will have the, just like in lamina, you will use the same limit. Also for the solid here, you will also use or have the same limit, because you have the same solid, but the changes is only for the integrand. Okay, so because we know that the centroid here, meaning that the density function is just delta, and you are looking for moment of mass respect to xy, so you have to put z. So z delta dv over the solid G. So now, as in finding the mass, so we will use the same order and the same limit, but only the difference is the integrand. So now you have z delta r dz dr d theta. So based on the mass that we have, so we use the same limit, 0 to 2 pi, 0 to 2, 0 to 4 minus r squared. Okay, I'm sorry about this one. So this one's supposed to be because you want to solve using cylindrical, so this one should be transformed into cylindrical. Delta r dz dr d theta. So 0, 0, 0, 2 pi to 4 minus r square. Sorry about that. And then you will get this. Okay. Okay, so now for the moment of mass for this. So you will first integrate the z, then you have the z here. Okay, so the z delta r will becomes your integrand. Okay, and again, I don't want to compute this for you, so please compute this for yourself. Okay, this is not so complicated, but it's not so simple. Okay. Okay, so now we have compute the z bar is m moment of mass divided by the mass. So based on the result that we obtain, we have 32 pi delta over 3 divided by 8 pi delta. So here the delta can be cancelled out and pi also can be cancelled out, and you have 32 over 3 8. So we have 1 4, so we have 4 over 3. So now we see that now the centroid, so we managed to get the z bar now is 4 over 3. So the x bar, y bar, z bar is at 0, 0, 4 over 3. Okay, which means that somewhere here. So that is your center. I mean the stability point, the centroid. So meaning that if you hang this particular solid and you have the rope, you put the rope here, and the solid is stable at this point. Okay. All right. But if you feel not so confident where the x bar, y bar, whether it is at 0 or not, you have to calculate. But then you need a longer time. Okay, but it's not always you can see that if you have something like this, I mean for a solid lying along the z-axis, so you always should say that the centroid is located at x 0 and y 0. It's not necessarily like that. It depends on your region, because we know that from the region it is a circle and the center of circle is at 0, 0. So you can see that the centroid is mean just like a center, right? The stable point is located at x 0, y 0. Okay, but if you just want to double check, do we need the 0, then you can provide the moment of mass with respect to yz, and also find the moment of mass with respect to xz and divide them by the mass that we already obtained. So I'm sure that you will get 0. You can try. Okay, so that is for this particular example, finding the centroid of the solid. Okay, so next, example 2.